Okay, today we're going to be talking about exponential functions, and exponential functions are functions that are used the most in the real world. We use them for the economy, physical happenings, interest is a big one, population growth and decay, for our census, and as well as material usage. It is always in the form of y equals a to the x, and a has to be bigger than 0, and it cannot equal 1, because 1 to any power is always and forever 1. So, we have talked about up, down, left, right, stretch, compress, reflect, all of that. We're going to apply what we know of up, down, left, right to exponential functions. When I graph this, we are simply going to make an xy table. 2 to the x is the parent function. And whenever we make an xy table, we choose two negative values, 0 and two positive values. I like to choose the ones closest to 0 because it's easier. And I like to start with 0. 2 to the 0 power is always and forever 1. 2 to the first is 2. 2 squared is 4. These are the numbers our brain can easily calculate. So 2 to the negative 1 becomes a fraction, and that's 1/2. 2 to the negative 2 becomes 1 over 2 squared, which is 1/4. So if I were to come over here and I graph what I just did, I'm going to be graphing the point 0, 1, 1, 2, 2, 4, negative 1, a half, negative 2, a fourth. Now, what your brain needs to understand is that this is the exponential graph. At the function y equals 2 to the x, I am going to blow this up. You are going to have an asymptote. The asymptote is going to be the horizontal axis, which is the x-axis, which is going to be y equals 0. And then you're going to have a y-intercept of 0, 1. That is the standard exponential graph, okay? This is what you're typically going to see. Now we're going to come back over here, and I'm going to change my pen color, and we're going to do this right here. What happens whenever you add 3 units to anything? Does it move it up? Does it move it down? Does it move it left? Does it move it right? If you said it moves it up, you are correct. So that means that this is going to go up 3 units. So when it goes up 3 units, what's happening is your x values stay the same, but your y values are going to be adding 3 to them. So your new y values are going to be 3 1/4, 3 1/2, 4, 5, and 7. Okay? Graphically, I don't even need that because all I'm going to do is I'm literally going to take this point, I'm going to move it up 1, 2, 3 units. I'm going to move this point up 1, 2, 3 units. I'm going to move this point up 1, 2, 3 units. I'm going to move this point up, and that should be there. I want to erase that a little bit. And then this point right here is going to be here. My other point is off the graph. What this means is y equals 2 to the x plus 3. My asymptote is now going to be y is equal to 3. It's going to get super close to the value y equals 3, but it's never going to cross it. My asymptote, my y-intercept, is now the point 0, 4. Why? Because you went from 0, 1 and moved it up 3 units to be 0, 4. Now, if you look right here, I have the point 0, 4, 1, 2, 3, 4, yep. I have the point 1, 5, 1, 2, 3, 4, 5, yep. And those points are all accurate. So this is what your brain is thinking as you're doing the graph. But whenever you have the original parent function and you know it's just a translation, you take every point and you simply move it up 3 units. Now, that means this one down here is going to be done very similar. But now I am going to take all of these values and I'm going to subtract 1 unit from them. So that's 3, 1, 0, and that's negative a half. And you are able to get all of those values then to give you negative 3/4. Do we all see that? Yes? So whenever I come over here to graph this, I go back to my original, but I'm going to go down 1 unit. Each point is going to go down a unit. And this is what you're going to have. So what this means is y is equal to 2 to the x minus 1, I have a new asymptote, and that's going to be y is equal to -1, and I have a new y-intercept, and that y-intercept is the ordered pair 0, 0, and that happens to be my x-intercept as well. You always have a y-intercept. You may not always have an x-intercept. That's what your brain needs to understand here. Due to the asymptote, the horizontal asymptote, you may not have an x-intercept. Okay? This is whenever we are doing an up and down vertical stretch, okay, or vertical translation. Now, what happens whenever we have a horizontal translation? Horizontal translation means, guess what? We're moving this function left and right. So -2, -1, 0, 1, 2, and this is going to be 3 to the first, or 3 to the 0, which is 1, 3 to the first, which is 3, 3 squared, which is 9, 3 to the -1, which is 1/3, and 3 to the -2, which is going to be 1/9. So if I graph that, I'm going to be at 0, 1, which is our original y-intercept. I'm going to be at 1, 3, and then 2, 9 goes off, -1, 1/3, slightly below 1/2, -2, 1, 9. This is your parent function, which means y equals 3x, I'm going to have an asymptote at y is equal to 0. And I'm going to have a y-intercept at the point 0, 1. Nothing new there. However, what do you think is happening to our second graph right here? Our second graph has x minus 1. This is going to be a horizontal shift rather than a vertical shift, which means -1, you think it's going to the left, but it's actually going to the right 1 unit. So it's going to the right 1 unit. What's happening is it is changing your x values. So what you're basically going to do is add 1 unit to each one of these. So if I'm adding 1 unit to each one of those, I'm going to have the x values being -2 plus 1 is -1. This is 0. This is 1. This is 2. And this is 3. The y values do not change. The y values do not change. So if I come over to my graph, I don't even need the xy table. I can simply take each one of these points and shift it to the right 1 unit. And that makes it so much easier for our brain to understand. What this means graphically is y equals 3 to the x minus 1. Your asymptote is still the same at y equals 0 because I didn't move it up or down. Your asymptote only changes whenever you move it up or you move it down. Okay, which means your y-intercept is now going to be this point right here, and that point is going to be 0, 1/3. Okay, 0, 1/3. If you're not certain, go back to your xy table and determine that. Okay, over here we had 0, 1. That was our y-intercept. That was our important point. Okay, so now we're going to go to the next one. And our next one here, we are moving this thing to the right 1 unit and up 2 units. So we are not only changing our x value, but we're also changing our y value. Now my x values are going to be taken from here. So we're going to be using these x values. So that means I'm in a -1, 0, 1, 2, 3. But my y values, I have to add 2 units to each of these. So 2 and 1/9, 2 and 1/3, 3, 5, 11. Which means if I come over here, I'm now going to take my green graph because my green graph is what I want to move up 2 units. So from here, I'm going to go 1, 2. From here, 1, 2. From here, 1, 2. And then from here, 1, 2. And that is going to be my graph. Y is equal 3 to the x minus 1 plus 2, which means my asymptote is now y is equal to this number right here, which is 2, because that is my vertical shift. Your vertical shift gives you your asymptote. Your vertical shift gives you your horizontal asymptote, okay? And then our y-intercept, looking back at our graph, our y-intercept is going to be this value right here. which if we look, that's 2 1/3. So that's 0, 2 1/3, and that is absolutely right. So that is the graph. Now, I showed you this information because we have been graphing a long time, and you can get all of this information on your graphing calculator if you wanted to. And I'm going to show you that right now by simply graphing a few of these. Okay, so if I go ahead and I graph this thing, and I put in there 2 raised to the x and hit enter, you can see that. If I go ahead and put tab 2 raised to the x plus 3, arrow to the right, and move it up 3 units, you can see that. If I hit Control T for my table, you can see the XY tables, and you'd be able to graph all of this on Desmos as well to be able to prove that what you're doing is correct. Okay? So, some things that you need to know for graph-wise whenever we're talking about the rules of exponents for exponential functions. Same base, you add the exponents. Same base, attached by division, you subtract the exponents. Power to a power, you multiply the exponents. Anything to the 0 power is 1. We've reviewed this already, you know this. Negative exponent goes to the bottom, makes it positive. I put the same one, I should have did the opposite. If I have a negative exponent in the bottom and raise it, put it to the top, it's going to make that positive then. All of these are true statements, and this is nothing but review for you. Okay, why do we need to know that? Because we need to know it for this concept right here. What is happening to this graph? Well, the plus c is not in the exponent position, so it's going to go up c units. This right here is not in the exponent position, so it's going to go down c units. This right here is plus c, that's squared, that's going to move it to the left, the whole entire function, but this is not an exponential function, this is a quadratic. So that's going to go to the left c units. This is still a quadratic, so this is going to go to the right c units. Okay? Now, this one right here is an exponential function. So since that's an exponential function, we apply the same rules up here, down here. This is going to go up c units. This is going to go down c units. This is going to go to the right c units. This is going to go to the left c units. This is going to be reflected when it's on the inside over the y-axis. And this is going to be reflected over the x-axis when it's on the outside. Okay? What do I mean by that? Let me go ahead and show you this, if I can get this to expand. This is what it typically looks like. When it's reflected, it's going to look like this. This is what it typically looks like. It's going to look like this. Okay? Okay, that brings us to the next usage. The next usage is going to be our interest formulas. Our interest formulas are very, very, very important information. This is literally how you are going to compound interest for any of your loans and things like that. So if we have a compound interest, the formula we're going to be using is A is equal to P parenthesis 1 plus R over N raised to the NT. A is your balance, P is your principal. What's principal mean? Principal is the amount of money that you took the loan for, okay, or the amount of money that you started your account for. R is the rate, make sure you change it to a decimal. N is the number of times it is compounded a year, and T is the time that you leave it in your lovely little account, okay? Now, we use this for quarterly, annually, monthly, or etc., and this is for our checking and our savings account. Now, continuously compounded interest is never given to us generally for our checking and savings accounts. They don't do that, okay? Ever, 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 ever. We wish that they would, but they don't. A equals PERT is whenever you have E being a number. E being a number. And the number that E is, you can actually put that in your calculator to see that. And if I do that, e to the first power, this is the decimal that you get, 2.71828. It's very similar to pi. It's an irrational number. and that is the number that you are going to be using to calculate things. You are still going to be using the formula of PERT, and you're still going to be using A as the balance, P as the principal, and R as the rate, and T as the time. This is used for all credit cards and loans from the bank, meaning if you ask to borrow money from them, they want that money back for every second of every hour of every day that you had that money. They want to get interest back and make money off of you. Whenever we give them our money into the bank, they don't want to give us interest for every second of every minute of every hour that they have our money to hold it. That's not the way it works, okay? This is only applied for loans, okay? Now, tonight's homework is going to be 3-1 worksheet 1. So let's go ahead and start that. We're going to use a calculator to evaluate the function at the indicated value of x. So number 2, all you are going to do here is you are going to take 8.6 -3, and you're simply going to plug it in. So I'm going to come over here to my calculator, and I'm going to type that in, 8.6 raised to the -3 times the square root of 2, but there's a negative here, and hit enter. And it gives you 9,220.22. That is your answer, 9,220.22. That is your answer. All this is a simple plug and chug, and you are done, okay? Next. Number 7, it says identify any asymptotes and intercepts and determine whether the graph of the function is increasing or decreasing. Increasing or decreasing is going on x values from left to right. Super important for your brain to understand, okay? So basically what we're doing is we're taking the parent function of 3 to the x, and what are we doing to it? We are moving it to the right 2 units and up 1 unit. That's what we're doing. So our brain needs to simply understand that if I graph 3 to the x, all I have to do is go ahead and say 3 to the first, or 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9, 3 to the -1 is a third, 3 to the -2 is a 1/9. So that means 3 to the x minus 2 plus 1 means I am adding 1 unit here, and I am going to go to the right, which means I'm going to add 2 units to each of these. Does that make sense? So my XY table, if I add 1 unit, that's 1 1/9. That's going to be 1 1/3. That's going to be 1 plus 1 is 2. 3 plus 1 is 4, and 9 plus 1 is 10. Okay? Over here, you're going to have 0. 2 minus 1 is going to be 1. 2 plus 0 is 2. 2 plus 1 is 3. And 2 plus 2 is 4. This is the graph that you would be graphing. Okay? And if you want, you can automatically graph the parent function first. 0, 3, then you can go ahead and say 1, 3, 2, 9. This is your parent function. This is y equals 3 to the x. So that means I'm going to take each of these points and I'm going to move it up 1 unit and to the right 2. 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 And there's your graph. So if I have y is equal to 3 to the x, and that was minus 2 plus 1, my asymptote is going to be my vertical shift, which is going to be y is equal to 1. And we see that graphically. We can very easily see that. Okay? My intercepts, my x-intercept, does this cross the x-axis? No, it does not, so I don't have an x-intercept. My y-intercept, however, is going to be at the ordered pair what? Well, that's going to be when x is 0, or whenever y is 0. So you are simply going to tell me that that ordered pair is right here. I just erased that, and I did not mean to. There we go. Is 0, 1 and a ninth. 0, 1 and a ninth. Okay? And is this function an increasing function or a decreasing function? So if I put myself on this graph, am I going up the mountain or am I going down the mountain? I am going up the mountain, so therefore this is an increasing function. Okay? You will have a decreasing function whenever it is a reflection. Okay? You will have a decreasing function when it is a reflection. And we don't have a reflection here, so therefore that's all you needed to do. Okay? So the next one is going to be number 9. Complete the table to determine the balance A for P dollars invested at rate R for T years and compounded N times per year. Okay, I am compounding it once, I'm compounding it twice, I'm compounding it 3 times, I'm compounding it 4 times, I'm compounding it 12 times, and I'm compounding it continuously. You need to do this and work smarter rather than harder. So A is equal to P parenthesis 1 plus R over N raised to the NT. That is the formula. Now you have to start plugging in the values that you know. Well, I know that my P is 2,500. My R is a percentage, and so that has to be turned to a decimal. So that's going to be 0.025. Over N, and N changes, and the time that I have that in there is going to be 10 years. Now, make yourself, it could be very easily done. We are simply going to put 1 in for N, 2 in for N, 3 in for N, 4 in for N, and 12 in for N. There are 2 ways you can do this. Okay? Go to your graphing calculator, and I am going to go to a calculator page. My principal was 2,500, parenthesis 1 plus, I'm going to put control division 0.025, raised to the 10 times, the N is what is in those positions. So if I want 1, I'm going to put a 1 there. So I'm going to arrow back and I'm going to put this down. I'm going to change the 1 to a 2. Or it's going to delete the whole thing, which is really magnificent, I might add. Change that to a 2, raise that to the 10 times 2, and hit enter. So it gives me this. And you can do that for every one of them. I am not typing that in every time. So what I'm going to do is I'm going to come back over to my lovely little graph. And where I see this, I'm actually going to put in an X in place of N. Why an X? Because our graphing calculator recognizes X as a variable. So if it recognizes X as a variable, that means I can put a new function in here, and I can make that function 2,500, parenthesis 1 plus control division 0.025 over X raised to the 10X. And I can hit enter. I do not care about the graph. What I care about is the XY table. At 1 year, I'm going to have $3,221. At compounded twice a year, I'm going to have $3,205.09. Compounded 3 times a year, I'm going to have $3,206.74. Compounded 4 times a year, it's going to be $3,207.57. And I can go down through here, and I can see all my values at 12 months, okay? I need to pause for 1 minute. Now, you can see that at 12, you have compounded monthly $3,209.23. Now, here's the kicker. This works great for the compounded problem, but if it's compounding continuously, like PERT is, then it does not work for that, which means we have to come back over here and you would fill all those numbers that we just talked about right here. But this last one requires different work. The last one, we use the other formula. The other formula has the $2,500, E 0.025, and then the time is T was 10. So you literally are going to come over here to your calculator, and I'm going to go over to my calculator and type in 2,500, and then pull the E right there, 0.025 times 10, and hit enter. And that means if I'm compounding every minute of every hour of every day for 10 years, and I leave it in that account, I will go from $2,500 to $3,210.06 in 10 years. Now, what does your brain understand from this? Your brain should understand that after 10 years of having my money in that account, a 2.5 interest rate is absolutely minuscule and not very helpful in your world. That is generally what a checking account and a savings account gets you. So what this means is whenever you are investing your money, you always want to look for an investment interest rate of being at least 5% to 10%. That would be magnificent, okay? That is how you are going to do that problem. Now, that brings us down to number 11. Number 11 says, complete the table to determine the balance A for T years compounded continuously. It says continuously. Continuously means I need to use the PERT formula. You are not using any other formula except for this. But what is changing in this formula is I know my 12,000, I know E, and I know my rate is going to be 0.04, but my time, T, is what is going to be my variable X. So I can go ahead and I can go to my graphing calculator, and I am going to, you can plug and chug if you would want to. My amount that I put in there is 12,000. And that's going to be E raised to the 0.04 times 1. Arrow up, grab that. You can change the 1 if you would want to be a 2 or a 20. And then you're going to get that. Okay? I like to do it a little bit differently. I like to go ahead and add another graphs page. And I like to type that value in there, it's 12,000 E to the 0.04x. And then I don't care about the graph, so I'm going to go ahead and hit Control T or go to my table. And I'm simply going to scroll and I'm going to look to see what my value is. Well, at 1 year, I'm going to have $12,489 and look down here, 73 cents. So 12,489.73. 12,489.73. Then at 10 years, I simply scroll down here to 10, and I look down here again, 17,901.90, because I'm rounding to the nearest cent. So 17,901.90, 17,901.90. Now, I can keep scrolling and do the 20 then. Or I could go here to menu, table, and you can change your table settings to have it start at 20 and to go by steps of 10. And hit OK, and it'll give you the 20, 30, 40, 50, 60, and you can have them all there. Okay? And that is super duper helpful for that. That is that section. If you have any questions, please ask me. I'll post the answer keys for you to check your answers. Okay?